So, think about if you were to drive to the grocery store this afternoon, right? You're relying entirely on muscle memory.
Oh, absolutely.
Yeah, like you merge onto the highway, you check your mirrors, you brake at the red light. And you probably do it while listening to music or something, barely even thinking about the actual mechanics of the pedals.
Right, it's completely automatic.
Exactly. But if you had to drive straight to the DMV right now, like today, and take your written driving test again, there is a very, very high chance you would fail.
Yeah, I'd probably fail it, honestly.
Right. Because the real world lets you roll through a stop sign if the road is totally clear, but the test demands a 3-second full stop behind that thick white line.
The textbook rules.
Exactly, the textbook rules. And that disconnect between daily experience and the textbook rules is exactly what we need to talk about today. We are taking a deep dive into the HashiCorp Terraform Associate 003 exam.
Yes, the big one.
Yeah. Our mission today, for you listening, is to decode the official study materials, break down the logistics, and uncover the specific, traps that are designed to catch seasoned engineers completely off guard.
And that disconnect you just described, I mean, it's the single biggest hurdle for candidates.
Really? Just the muscle memory thing.
Yeah, because, well, you might use Terraform every single day to, provision infrastructure for your company. You feel confident.
Sure.
But this exam isn't just checking if your code deploys.
Yeah.
It is meticulously designed to test your knowledge of edge cases, strict architectural terminology, and the foundational guardrails of the tool.
Right.
So relying purely on your daily muscle memory it will actively lead you to the wrong multiple choice answers.
Okay, so to prepare you for what you're walking into, we need to map out the physical, or I guess virtual room first. What are the sheer logistics of sitting down for the 003 exam?
Well, the environment is highly constrained, so that requires a really specific pacing strategy. You're facing 57 questions, and you have exactly 60 minutes to complete the whole thing.
Wait, wow, so you have just barely over a minute per question.
Yeah, it's tight.
That's like around 60 seconds to read the prompt, parse the HCL code if they provide a snippet, evaluate the distractors, and lock in an answer. There's zero time to mentally debate it.
Precisely. Rapid-fire decision-making is basically non-negotiable.
Wow.
And you can take the exam via, an online proctor or at a physical test center, and the current cost sits at $70.50.
Okay, not too crazy.
Right. And you're aiming for a passing score of around 70%.
Right.
But the key to actually getting that score
Yeah.
lies in understanding how the exam is weighted.
Right, because there are 8 objective domains,
Right.
right? But they aren't created equal.
Exactly. The bulk of your score comes from 3 specific domains. That's infrastructure as code concepts, Terraform basics, and state management. Because the exam writers, they want to ensure you comprehend the underlying philosophy of the tool, not just the command line syntax.
Well, since state is such a massive chunk of that grading rubric, we should probably tackle the mechanics of state management first, right? The danger zone.
Let's do it. It's definitely a danger zone.
Because reading through the materials, I realized my own mental model was completely flawed.
Oh, yeah. How so?
Well, okay, let's unpack this. I was looking at the notes on the sensitive equals true flag. Yeah, my immediate thought was, awesome, if I mark, a database password output as sensitive, Terraform automatically encrypts it in the state file.
Right, which makes logical sense.
Yeah, but the study guide emphatically says otherwise.
It is arguably the most common misconception candidates have, and the exam writers, they exploit it relentlessly.
Yeah.
The sensitive equals true flag does not perform any cryptographic encryption in your state file. 0.
So it's basically just a cosmetic UI feature.
Yes, exactly. It literally just prevents the data from being printed in plain text to your command line interface.
Oh, wow.
So when you run Terraform apply, instead of showing your database password on the screen where, a coworker walking behind your desk might see it,
Right.
the terminal simply outputs the word sensitive in brackets. But if you crack open the actual terraform.tf state file, which is just this massive JSON document sitting on your hard drive.
Or in a bucket somewhere.
Right.
Right.
That password is sitting right there in completely plain text.
Man, that is a critical distinction for the exam. It hides the data from human eyes on the screen, but it does absolutely nothing to protect the data at rest.
Nothing at all.
Which naturally brings us to where that state file actually lives. We know the local backend is the default when you run Terraform for the first time. The state JSON just sits in your project folder.
Right. And if you're studying for the exam, you need to understand why keeping it local is a massive operational liability for a team.
Because of the locking, right.
Exactly. The local backend has absolutely no native state locking.
Okay, let's visualize what that actually means for a second. If developer A and developer B are on the same team and they're sharing a local state file through, I don't know, a network drive or something.
A very bad idea, but yes.
A terrible idea. But they both hit Terraform apply at the exact same millisecond. What actually happens?
Well, you trigger a race condition. Terraform is attempting to update the same JSON file simultaneously. One process overwrites the other, the file gets corrupted, and suddenly Terraform totally loses track of what exists in your cloud environment.
Yikes. So you just have unmanaged floating resources everywhere.
Exactly. It's a nightmare. So to prevent that, enterprise teams use remote backends.
Right. And the most heavily tested remote backend on this exam is AWS S3.
By far.
But there's a massive red herring in the exam questions regarding S3, isn't there? Because you can't just drop your state file in an S3 bucket and call it a day.
No, you can't. S3 is excellent for, redundant, secure file storage. But historically, S3 did not provide the atomic locking mechanism required to prevent those race conditions we just talked about.
So if an exam scenario asks you to design a, fully functional, safe S3 backend, choosing just S3 is the wrong answer.
Completely wrong. You are strictly required to pair it with DynamoDB.
Okay, how does DynamoDB actually solve the race condition, though?
Well, DynamoDB is a highly scalable NoSQL database. When Terraform wants to modify your S3 state file, it first writes a simple lock ID to a DynamoDB table.
Oh.
It acts exactly like a padlock. If developer B tries to run an apply, their Terraform checks that DynamoDB table, sees the padlock, and gracefully errors out, saying, hey, state is currently locked by developer A.
Ah, so S3 holds the file and DynamoDB holds the padlock.
Exactly.
That makes perfect sense when you break down the mechanics. Now, HashiCorp obviously has its own managed service too, Terraform Cloud.
Yes, they do.
And a lot of candidates seem to assume that to get that kind of seamless remote state management, without managing DynamoDB yourself, you have to upgrade to a paid enterprise tier.
And that's another huge trap. Do not let the exam trick you into thinking remote state is locked behind a paywall.
Really? It's not.
No. The Terraform Cloud free tier absolutely supports remote state storage and locking. HashiCorp, they actively encourage individual developers to adopt their ecosystem so that core feature is completely free.
That's good to know. Okay, when comparing Terraform open source to Terraform Cloud, the study materials highlight a terminology collision that feels, honestly, almost unfair.
Oh, you're talking about workspaces.
Yes.
Yeah.
The word workspace means entirely different things depending on which version of the tool you're discussing.
It is a fascinating quirk of the product's evolution. If an exam question asks about Terraform open source, a workspace is just an alternate state file within the same local directory.
Like a branch in Git.
It's exactly like a Git branch. You can spit up a dev workspace and a prod workspace. And Terraform simply routes your actions to two different local JSON files.
But if the question specifies Terraform Cloud,
then the definition totally explodes in scope. In Terraform Cloud, a workspace is a comprehensive, isolated environment.
Okay, meaning what exactly?
It bundles your Terraform configuration code, your specific variable values, your cloud credentials, and your state file into one unified package. It's much more than just a separate state file.
Got it. It's an entirely isolated execution environment.
Exactly.
So, okay, if your state is safely locked in the cloud and your workspace is defined, you actually have to execute the code. You have to open your terminal.
Time to run some commands.
Right. This shifts our focus to the CLI, the command line interface. And just like we said at the start, your daily muscle memory in the CLI can actually betray you here.
Oh, absolutely. The CLI questions, they separate the practitioners who just copy-paste from Stack Overflow from those who actually understand the architectural mechanics.
Yeah, I was sketching out an analogy for this based on my notes. Look at the command Terraform validate.
Good example.
In my head, I treat Terraform validate exactly like the spell checker in a word processor. Like if I run it, it checks my syntax, it verifies my HashiCorp configuration language, has the correct brackets, the right argument names, indentation, whatever.
Right, it checks the spelling and grammar.
Exactly.
Yep.
But it has absolutely no concept of whether my logic is sound or my facts are real.
That is a brilliant way to conceptualize it. The distractor on the exam is suggesting that Terraform validate verifies your config against your cloud provider's API.
Which it doesn't.
It does not.
So if I write a block of code requesting an AWS server, and I invent a completely fake size, like a super mega large 99.
Which would be an awesome server. But
yeah. What does validate do?
It passes with flying colors.
Wow.
Yeah, Terraform Validate is entirely offline. It looks at your code and says, well, the syntax for requesting a server is perfectly valid. It isn't until you run Terraform Plan or Terraform Apply that the tool actually reaches out to the AWS API.
And then AWS is like, that instance type doesn't exist.
Exactly.
Speaking of reaching out to AWS, how does Terraform actually know how to talk to Amazon or Google Cloud or Azure?
So Terraform Core is actually quite dumb. It only knows how to read HCL code and manage a state graph.
Okay.
It relies entirely on providers, which are essentially just third-party plugins.
And those plugins have to get onto your machine somehow, right?
Exactly. When you run Terraform init, Terraform scans your code, sees you want to interact with, say, AWS, and goes out to the public registry to download the specific AWS provider binary.
Which exposes a major blind spot for daily users. Because those plugins are downloaded during initialization, Terraform init is strictly required anytime you modify your provider requirements. So if you add a new provider to your code, or if you bump the version number from, like, 4.0 to 5.0, you cannot just run and apply. It will fail.
Right. You must rerun init to fetch the new plugin binary. If you don't grasp that providers are physically downloaded executable plugins, that exam question will totally trip you up.
Makes sense. Okay, here's a command I used to run constantly. Terraform refresh.
Yes. Well, if you look at the broader evolution of the tool, Terraform refresh used to be standard practice.
Right.
It reaches out to your real-world cloud infrastructure and updates your state file to match reality. But HashiCorp officially deprecated it.
Deprecated. Wait, why pull a useful command? What is the candidate supposed to use instead?
You must know to use the -refresh only flag attached to a plan or apply command.
Okay, so Terraform plan -refresh only.
Exactly. The danger of the old standalone refresh command was that it mutated your state file immediately, like in the background, without giving you a chance to review what was about to happen.
Oh, I see. That's scary.
Very. By forcing you to use the -refresh only flag, Terraform generates a speculative plan first. You get a safety net to review the proposed state updates before they're actually committed to your backend.
Safety first. I appreciate that. Now, what about Terraform FMT? I am obsessive about a neat code base.
Well, it's a fantastic utility. Terraform FMT rewrites your configuration files to a standardized canonical format.
Fixes the spacing, aligns the equal signs.
Exactly. But the exam pitfall is believing it does anything functional. It is purely aesthetic. It does not check for logic errors, and it does not validate your syntax.
Got it. Let's talk about destructive commands. The study materials explicitly red flag a specific command as highly dangerous. Terraform destroyed -target.
Yeah, this one tests your understanding of dependency graphs. In Terraform, resources are inherently linked.
Like a chain.
Right. A web server depends on a security group, which depends on a subnet, which depends on a virtual network.
Right.
If you use the -target flag to force Terraform to destroy only one specific piece in the middle of that web.
So you target the subnet.
Exactly. Then you risk leaving your web server and security group in a broken orphan state.
Yikes.
The exam considers -target to be a break glass in case of emergency tool. It's meant for recovering from severe state failures.
So if a multiple choice option suggests using -target as a routine, daily best practice.
It is a distractor. Avoid it at all costs.
Okay, finally for the CLI section, a quick hygiene check. When we run Terraform init and download all those massive provider binaries and backend configs, where does all that stuff actually go?
It's stored in a hidden directory in your project folder called .terraform.
And the cardinal sin here is pushing that folder to your source control.
Oh yeah. Always ensure the .terraform directory is in your .getignore file.
Because you never want to commit hundreds of megabytes of OS-specific executable binaries, right?
Or local backend configurations containing sensitive tokens. Never put that into a GitHub repository.
Never. Okay, ultimately, a command is only as effective as the code it executes. We've secured our state, we've navigated the CLI quirks, but we need to examine the HashiCorp configuration language itself. HCL.
This is a heavy transition.
Yeah.
Developers coming from general-purpose programming languages almost always hit a wall when they first learn HCL.
Yeah, it requires a fundamental rewiring of your brain. Like if I'm writing Python or JavaScript, I'm writing imperative scripts.
Right.
I write step 1, then step 2, then step 3. How does a candidate need to shift their perspective for HCL?
Well, HCL is fundamentally declarative.
Okay.
In an imperative language, you define the how, like log into AWS, spin up a server, name it web A, wait for it to boot, attach this IP address.
You write the step-by-step recipe.
Exactly. In a declarative language, you only define the what. You describe the final desired end state. You just write, I want a server named web A with this IP address.
And then
You hand that config to Terraform, and its internal engine figures out the complex web of API calls required to make reality match your description.
Wow. So if a question implies that Terraform creates resources from the top of your file to the bottom sequentially.
That is a total misconception. Terraform builds a massive internal dependency graph and figures out the most efficient order of operations itself.
So the physical layout of your code blocks doesn't actually dictate the execution order.
Not at all.
Man, that declarative nature dramatically changes how we handle repetitive tasks like loops. And the exam heavily tests the difference between the count and for each meta arguments.
Yes. Both allow you to provision multiple identical resources, like, spinning up 5 web servers without copy-pasting the code block 5 times.
Thank goodness for that.
Right. But they handle the underlying indexing in radically different ways. When you use count, Terraform creates a list. It tracks your servers using integer indexes.
0, 1, 2, 3, 4.
Exactly.
Okay, let's use a moving box analogy here. Using count is like packing 5 identical boxes and just writing 0, 1, 2, 3, and 4 on the outside with a Sharpie.
Exactly.
Yeah.
And using for each creates a map. Instead of numbers, the resources are indexed by meaningful, unique string keys that you define. So instead of numbers, you label your boxes kitchen, bedroom, living room.
Okay, but why does that distinction matter so much operationally?
Because infrastructure changes over time. Let's say you used count, and you decide you no longer need the server at index 1. You remove it.
Okay.
Terraform looks at the list and shifts everything below it up to fill the gap. Index 2 becomes the new index 1. Index 3 becomes the new index 2.
Oh, I see where this is going.
Yeah, Terraform sees that massive index shift and might decide to completely destroy and recreate all those downstream servers just to align with the new numbering.
That's incredibly destructive.
It really is. But with for each, because the servers are mapped to unique string names, you can safely delete the kitchen server, and Terraform leaves the bedroom and living room servers completely untouched.
That is an operational game changer. And right next to for each, there's a syntactic rule that constantly catches people out. You cannot feed a standard list directly into a for each block.
No, you absolutely cannot. If you have a simple list of strings, say apple, orange, apple,
Okay.
you must convert it to a set first, typically using the toSet function.
Because mathematically, a list can contain duplicate values, right? Like the 2 apples.
Yes.
Yeah.
But a for each map strictly requires unique keys to identify each resource. A set is a mathematical collection that guarantees every item is unique. It automatically strips out duplicates.
Oh, wow. So if you try to pass a list into for each without converting it to a set,
Terraform will just throw a syntax error.
got it. toSet is your best friend.
Yes, it is.
Moving on to timing, the sources emphasize preconditions and postconditions.
Right. These are custom validation rules you can bake into your code to verify assumptions.
Yeah.
The key for the exam is knowing exactly when they trigger.
Okay, breach it down.
Preconditions run during the plan phase. They evaluate your logic before Terraform even attempts to figure out what needs to change in the cloud.
Makes sense. And post.
Postconditions run during the apply phase, immediately after a resource is created or updated, to ensure the final result actually meets your criteria.
So pre is during the plan, post is during the apply. Keep that straight.
Exactly.
Okay, for the final stretch of our deep dive, we're pulling back the camera. We're moving from the workstation of a solo practitioner to the constraints of an enterprise organization.
Because when you scale up, the rules of engagement change entirely, and HashiCorp tests your knowledge of those enterprise-grade best practices.
Let's look at support first. The materials bring up the TAM, the Technical Account Manager.
Right.
If I'm running a massive open source Terraform deployment, or if I'm, say, paying for a standard tier of Terraform Cloud, can I get a dedicated TAM on the phone?
No, you cannot.
Really?
Nope. A Technical Account Manager is a dedicated human HashiCorp expert assigned to guide your specific organization. It's an expensive, high-touch resource.
So assuming it comes standard is a pitfall.
Exactly. A TAM is exclusively available in the Terraform Enterprise or Terraform Cloud Business tiers. Nowhere else.
Okay, so you have to pay for the top-tier enterprise package to get the human expert. Got it. Now, what about code sharing at scale? Enterprises rely heavily on modules pulled from private or public registries.
They do.
But there is a strict best practice about how you reference those modules.
Oh, definitely. When you source a module from a registry, the exam wants to see that you always pin your module versions. Like you lock your code to version 1.2.0, for example.
Because if you just lazily point your code to pull the, quote-unquote latest version...
Oh, disaster waiting to happen.
Right. If the maintainer pushes an update tomorrow with a breaking architectural change, the next time your pipeline runs Terraform init, it downloads the breaking change and your infrastructure just blows up without warning.
Exactly. Version pinning guarantees stability. You lock the version, and you only intentionally upgrade it when you have the bandwidth to thoroughly test the changes in a staging environment.
Smart. And since you mentioned a CI/CD pipeline, like an automated robot that deploys your code, we need to talk about security.
Crucial topic.
If my pipeline needs to authenticate to AWS to build infrastructure, I could just, generate an access key and a secret key and hand it to the robot, right?
I mean, you technically could, but the exam actively pushes against it. From a security posture, the golden standard is utilizing dynamic credentials instead of static keys.
Why are static keys considered such a liability, though?
Because static keys are permanent. They live forever until you manually revoke them.
Oh, true.
So if a static key gets accidentally committed to a GitHub repository or exposed in a raw pipeline text log, malicious bots scraping the internet will find it in seconds and just hijack your cloud account.
Terrifying. So how do dynamic credentials fix that?
Dynamic credentials utilize OIDC, OpenID Connect, to generate short-lived temporary tokens.
Short-lived being the keyword.
Exactly. The pipeline requests a token, Terraform provisions the infrastructure, and 15 minutes later, the token naturally expires and becomes totally useless.
Wow, so the blast radius of a potential leak is reduced to almost zero?
Exactly. Dynamic credentials are the answer.
And really, if we step back and look at everything we've unpacked today, from the sensitive flag hiding data but not encrypting it, to the spell checker nature of Terraform Validate, to the dangers of dash target, to for each requiring mathematical sets, I mean, these aren't just random trivia facts.
No, they're not. They actually form the foundation of the exam's distractors.
Really?
Yeah. The exam writers know exactly how developers misuse the tool in their daily jobs. If you synthesize the most common wrong answers on the 003 exam, they are simply the exact inverse of everything we just covered.
So they deliberately designed the multiple choice options around your daily blind spots.
Exactly.
Wow. So passing the Terraform Associate 003 exam in a blistering 60 minutes requires vastly more than just knowing how to build a server. It demands a really rigorous understanding of the deprecated commands, the strict definitions, and the specific limitations of the CLI.
It demands a level of precision that your daily muscle memory simply cannot provide.
But armed with the knowledge of these specific mechanisms, you are more than ready to navigate the tricky wording. You know the textbook rules. You know how to stop behind the white line.
You're ready for the DMV.
Exactly. But before we wrap up, I want to leave you with a fascinating contradiction to ponder as you continue studying.
Yeah, think about this. We spent a lot of time today emphasizing HashiCorp's core philosophy, right? Terraform is a purely declarative tool. You're supposed to simply describe your idyllic end state, hand it off, and let the internal engine do all the heavy lifting.
Sounds like magic.
Right. But considering that engineers have to meticulously manage NoSQL lock tables to prevent race conditions, worry about the precise execution timing of preconditions versus postconditions, and, manually inject dash refresh only flags to prevent background state mutations.
Yeah.
At what point does managing a strictly declarative tool force us to start thinking imperatively, just to keep our infrastructure from collapsing?
Oh, man. That is a brilliant paradox to chew on.
It really is.
Because no matter how advanced and hands-off our tools claim to be, they still require an engineer deeply aware of the mechanics pulling the levers under the hood.
Exactly right.
So when you sit down in that testing room, trust your knowledge of the textbook rules, spot the red herrings, and you are going to absolutely crush it.